Tonight, on the Dreamy Physicist, you drift beneath a sky that hides its expansion in silence. You feel the hush between stars, and we will follow it into the very breath of the cosmos itself. Hi there. I'm so glad you're here. Let the day fall away now. Let your body soften like a ripple returning to still water. You don't need to hold anything, not thoughts, not time, not answers. Just float with me. Let's journey together into a question older than memory. What does it mean for space itself to grow? You close your eyes and let your body melt into the invisible fabric of the night. Above you, beyond the ceiling, beyond the air, the stars wait in a velvet sky woven with ancient light. But even that silence, so still and slow, is not as still as it seems. The darkness between the stars isn't just distance, it's space itself. And that space is stretching. Not like something moving within space, but space becoming more space, right between your fingers, your ribs, your thoughts. Once, long ago, so long it humbles time itself, everything, that is, was folded into a single point, not a dot, sitting in darkness, but a place where even darkness didn't yet know how to exist. And then, not with a bang, but with an opening, a beginning of becoming, the universe didn't explode into something. It unfolded as something, an unfurling bloom of space and time, curled tight in possibility, stretching out its petals into stars, matter, light. And you were always part of that beginning, not separate from it, but made from it. Every cell, every atom of you once existed in that first fire as pure potential, as vibration, as promise. When people speak of the Big Bang, they often imagine noise, chaos, a burst like fireworks. But it was quieter than that. It was expansion, not explosion, a soft and steady swelling of space itself. Imagine a balloon, gentle in your hands, being slowly filled, but not with air, with the distance between galaxies. The galaxies aren't flying outward like sparks from a flame. Instead, they ride the stretching of space, like leaves resting on the surface of an inflating bubble. Even now, right now, as you lie here, space continues to stretch. The stars you see are farther than they were last night. The light they shed took millions, sometimes billions, of years to reach your eye, and all the while, the space it crossed was expanding beneath it. This stretching doesn't need a center. It isn't happening from somewhere. It happens everywhere, all at once. Like dough rising in a quiet kitchen. The more space there is, the more it grows. Like a whisper, becoming an echo, becoming a song across cosmic time. And though it feels unreal, that space itself can change its own size. The evidence surrounds us. The galaxies drift farther, their light tinged red by the stretching of the universe's frame. This redshift, soft as a sigh, is the universe's way of telling its story backwards. You are not drifting from the universe. You are drifting with it. You are folded into its pattern, woven into its fabric. You are space, stretching gently into more of itself, And though your feet touch the earth, your body belongs to the stars, not just poetically, but physically. The hydrogen in your breath was born in that first unfolding. The iron in your blood was forged in dying stars that exploded to seed the sky. You are not beside the cosmos. You are not beneath it. You are within it, and it is within you. Tonight, as you breathe slowly and listen to the hush, know this: you are part of a quiet, continuous blooming, a cosmos still expanding, still stretching, still unfolding its ancient map beneath your resting body. You may wonder, why? Why does the universe grow instead of settling still? What is this unseen hand nudging galaxies apart, as if drawing the stars away from one another's embrace? There is no wind you can feel, no sound you can hear, but something without a face or name, is there, threaded into the cosmos, urging it open, like fingers parting a curtain. This something has no glow, no warmth, no familiar texture. It does not flicker like fire or bend like light. It leaves no footprint, but pulls everything apart with tender, relentless patience. It is not gravity, which gathers, pulls in, embraces. This force does the opposite. It urges everything outward, like breath exhaled forever. Astronomers once thought the universe might slow down, cool, collapse, fold in. But that is not our path. Instead, the stretching quickens, like a tide that no moon commands. This revelation shook the sky as deeply as it shook the minds that studied it, and they gave it a name that sounds more like mystery than truth. Dark energy, invisible, untouchable, immeasurable, except by its effect on everything. Dark energy is not a thing you can hold. It is presence, felt in absence, a story told by what drifts apart. We know it is there because galaxies scatter like dandelion seeds. We know it is strong because not even gravity can slow it down. And yet, we know almost nothing else. Is it woven into the fabric of space itself? Is it constant? Will it someday fade or grow beyond what the stars can bear? We don't know. And maybe we're not meant to. Not yet. But as you lie here tonight, held in the hush of a breathing, stretching cosmos, you can feel it, this presence with no form, the silent whisper that tells space to become more space, the quiet rhythm that makes the universe bloom. And so, you ask, what is this force, this faceless sculptor of the cosmos? And where does it go when the stars are too far to ever return? There is a kind of silence that does not mean absence. It means presence. So subtle, so woven into the fabric of things that it escapes our eyes, our hands, even our thoughts. This chapter is about such a presence, a quiet force with no face. You wait, still wrapped in the mystery we left behind. Space stretching, not by accident, but by some unseen will. You lie on your side, in the hush of your room, while galaxies drift apart in an endless outward sigh. You can't hear it, but the universe is whispering its secrets again, one of which is this: something is making space grow faster, not slower, not still, faster, as if the universe, far from tiring, has found its second wind. And we call that something dark energy. But the name is not a truth. It is a placeholder, a shadow cast by something we can't yet see. Dark, not because it is gloomy, but because it hides from detection. Energy, because it does something. It acts. It changes everything. You might imagine a wind blowing galaxies apart. But this isn't wind. It doesn't come from anywhere. It is the fabric itself changing how it moves. It doesn't push with fingers. It doesn't pull with ropes. It is a pressure that lives in the emptiness, as if nothing has learned to grow. Long ago, before we knew to ask, scientists believed that gravity alone held the story. They thought the universe's expansion would eventually slow, halt, maybe even reverse. Galaxies would fall inward again, a grand collapsing, a cosmic breath returning. But when they looked, truly looked, they saw something stranger. Distant galaxies weren't just far. They were moving away faster than closer ones. This meant that the universe's expansion was not decelerating, it was accelerating. This revelation arrived like a whisper in the early 1990s, quiet, inconvenient, impossible to ignore. And so the search began for this hidden hand, this force, with no face. No one saw it. No telescope captured it. But its effect was too vast to be denied. It was like noticing your boat is drifting faster without wind or paddle and realizing the river itself has come alive. Dark energy, a term wrapped in mystery, a confession of not knowing. And yet, we map it by its fingerprints, by the distance between galaxies, by the faint afterglow of the Big Bang, a light still echoing through the sky, the cosmic microwave background. A dim hum of ancient warmth reveals the early universe's secrets. In it, we find the first clues of dark energy's whisper. It makes up about 70% of the entire universe. Let that sink in. All the stars, planets, galaxies, dust, you, me, everything we can see or touch, make up less than 5%. Another 25% belongs to dark matter. Another silent presence we'll meet later. But the vast majority, the deep ocean beneath all of it, is dark energy. And yet, we don't know what it is. Not a particle, not a wave, not a thing you can bottle or name. Some think it might be a property of empty space itself, a vacuum with pressure, a stillness that pushes. Einstein, with his furrowed brow and chalk-dusted fingers, once introduced a concept he called the cosmological constant, a way to balance gravity so the universe wouldn't collapse. Later, he called it his greatest blunder. But maybe it wasn't a blunder. Maybe it was a glimpse of something real, something he saw without yet knowing what it meant. Maybe dark energy is that constant, a quiet woven into space, everywhere, always. Or maybe it's something stranger. Some believe it could be a field, a dynamic sea, changing through time. Others wonder if it is tied to dimensions we cannot yet reach, like echoes from beyond the edge of what we call real. You don't need to decide. You don't need to solve. Tonight is not for solving. Tonight is for feeling the gentle ah of not knowing. Because not knowing is part of being human. You are not smaller for lacking the answer. You are wider for holding the question. And so you breathe deeply, softly, like the universe itself expanding in your chest. This dark energy, this faceless presence, will shape the fate of everything. If it grows stronger, the stars may scatter into perfect loneliness, so far from each other that light itself can no longer bridge the gap. If it stays steady, the cosmos will cool, settling into a deep stillness, a soft dimming of all light. And if it fades, then gravity may gather again and draw the universe back inward in a final embrace. We don't know. We cannot see far enough. Time itself must unfold more chapters before we understand. But even in this moment, you are part of that unfolding. Your breath, your blood, your heartbeat exist inside this quiet force's reach. It does not care that you are small. It does not care what you believe. But you, in your quiet wonder, can choose to feel its presence, not as fear, but as belonging. You are not lost in a random storm. You are sailing a living ocean that stretches beneath the stars. You are here, awake within a question that even galaxies cannot answer alone. So rest now in the curve of the cosmos. Float gently. Your mind wrapped in the soft tension between knowing and mystery. And ask, if space stretches and dark energy grows, what keeps it all from tearing apart? What holds stars in their spirals, galaxies in their dance, your atoms in their delicate embrace? There are moments in the long life of the universe when something is discovered and nothing ever feels still again. Tonight, you drift into a moment like that, a turning point, a hush before the gasp. It begins quietly, as most great revelations do, not with thunder, but with light from the past. You lie here, your body slow and soft, while somewhere in a telescope's memory, a light flickers from billions of years ago. Not the light of a sun, or a fire, or a torch, but the light of a supernova, a star that has ended, and in ending has told us a truth we didn't know how to bear. Close your eyes. Imagine a star, not like ours, not young and golden, but old, white hot, burning itself down. This star lives in a quiet binary system, two stars orbiting close, their fates knotted together. One of them, a white dwarf, gathers matter from its partner until it reaches a limit, a tipping point. And then, silently, instantly, it ignites in collapse. Type supernova, a perfect explosion. So consistent that we use them as cosmic rulers. They always shine with the same intrinsic brightness, like identical lanterns, hung at different distances. We know how bright they should be. So by comparing what we see with what we expect, we can measure distance. with elegant precision. In the 1990s, two teams of astronomers set out to map these stellar explosions to see how the universe had expanded over time. They expected to find the universe slowing down. Gravity, after all, should have been pulling on everything. But what they found instead was a shock. The faraway supernovae were dimmer than they should have been, not because of dust, not because of error, but because they were farther than expected. The expansion of the universe was not slowing, it was speeding up. The stars, so careful, so predictable, were telling a new story, one that made even the stars themselves shiver. This moment, this breathless pause in our knowing, is one of the most profound in scientific history. We had discovered that something unseen was acting on the universe, accelerating its expansion, ripping space wider, quieter, faster. This was the birth of what we now call dark energy, the silent sculptor introduced in the chapter before. But in this chapter, you feel the moment. It was born in us, not the force itself, but our awareness of it, the realization that we had misunderstood something fundamental, that we, for all our instruments and insight, had only glimpsed a sliver of the sky's intention. Astronomer Brian Schmidt called it a gut punch. Saul Perlmutter called it beautiful. Adam Rees stood in the middle of the evidence and watched the world change. The Nobel Prize came later, but wonder came first. And now you are here, years after that revelation, feeling its echo. You see, when we say the stars shivered, we don't mean fear. We mean awe. We mean truth arriving with such clarity that even ancient light could not hide from it. This was not just a scientific moment. It was a human one. We had thought the universe was slowing down. We had written that story into our models, our textbooks, our bedtime beliefs. But the sky disagreed. And in that disagreement, a new humility was born. You lying here tonight know this feeling too. The feeling of being certain until something gently pulls the ground from beneath your thoughts. But isn't that how we grow? By letting go of what we thought was fixed. The stars, in their long burning honesty, gave us a gift by dying loudly. Supernovae are not only ends, they are cosmic bookmarks, marking time on the grandest scale. By tracking them, we mapped the universe's heartbeat, and in its rhythm, we heard a stutter, a speed up, a secret. It is poetic, don't you think? That something so violent, a star's death, could teach us about the universe's expansion and its deepest force? That even in collapse, there is meaning? That the dark can speak light? You are floating now in this soft thought as though your body were suspended in the fabric of space itself. And perhaps it is. Perhaps we are all adrift on this swelling sea, this silent expansion that began before Earth even formed. Even now, more supernovae are being spotted, more data gathered, more refinements made. We know more than we did, but the mystery still lingers. Dark energy is not explained by this discovery. It was revealed by it, and revelation is just the start of the search. We don't know if dark energy stays constant. We don't know if it evolves or fades or pulses like a hidden heart. But we do know that the light from the stars, those brave, burning storytellers, carried to us a message written in fire, a message that said, the universe is not slowing down. It is racing forward, and you are part of that motion. So you breathe that in now, the acceleration of space, the vast reach of change, the quiet fact that nothing stays as we expect. And as your breathing slows, you wonder if the universe can turn its story on its head. What else might be hiding in the light? What more might the dark be trying to say? You've heard the word so many times. Vacuum. It sounds so clean, so absolute, like space that has been tidied up and left to rest. You imagine it as a place without light, without air, without matter, a total hush in the house of the cosmos. But what if that hush is not silence? What if the vacuum isn't empty? Tonight, your thoughts float out into that supposed nothingness, the space between stars, between atoms, between the particles that dance through your bones. You drift into that darkness now, trusting it to hold you. And the deeper you fall, the more you begin to feel a strange hum beneath the silence, a trembling, like the stillness of a pond that ripples without wind, because the vacuum, you see, isn't a lifeless void. It is a sea of potential, a quiet, restless field that never truly rests, even when all the particles have vanished, when all the photons have gone dim, when matter has stepped out of the room. The vacuum still stirs. Physicists call it vacuum energy, but you don't need equations to feel it. You only need to listen to what isn't being said, even in this moment, as you lie still, your body adrift. In the soft dark of the bedroom, the vacuum outside your walls is not truly still. It flickers. Pairs of particles blink into existence and then disappear, like dreams that form and fade before memory can catch them. They come in pairs, particle and antiparticle, borrowed from the energy of the vacuum itself, existing for less than a whisper of time before vanishing again. We call them virtual particles, not quite real, but not quite imaginary either. They are the tremble beneath space's calm face. They are the reason why emptiness is never truly empty. Imagine the vacuum now, not as a blank slate, but as a canvas already buzzing with invisible brushstrokes. Everywhere you look, even in the coldest corners, between galaxies, this invisible dance goes on. And when you ask why the universe expands the way it does, you begin to wonder, could the vacuum itself be the source? Could the very fabric of nothingness be pushing everything apart? Some scientists believe that dark energy might be rooted in this vacuum energy, in the quiet hum of space itself, like a sponge swelling slowly, not because of what's in it, but because of the space between. If that is true, then every point in space has a kind of pressure, a push, A whisper saying, expand. You are part of that, even now. The molecules in your skin, the space between neurons in your brain, it is all soaked in this restless vacuum. Not inert, not asleep, but full of invisible movement. It's almost too much to believe, isn't it? That something we once called nothing might be the most powerful force in the cosmos. That empty space might be the thing that's driving galaxies apart. That silence isn't silent. This shifts something in you. You are taught to see space as background, as the stage on which matter performs. But what if space is a character too? What if it acts, not just reacts? In quantum field theory, every particle is a vibration in a field that exists everywhere. There's a field for electrons, a field for quarks, a field for photons. And these fields do not go away. When the particles disappear, they remain, tuned, trembling, like strings waiting to be plucked. Even in a vacuum, the fields are still there, still humming, still alive. And because of this, there is energy, even in absence. The vacuum is never truly at zero. It is a lullaby sung by the fabric of being. And this changes how you think of darkness, not as the opposite of light, but as a medium with music of its own. Not a void, but a veil. This leads you gently to a thought as strange as it is profound. If space itself contains energy, then that energy has mass, and mass has gravity. So even nothingness can pull on the universe. Even absence can create presence. That idea stirs something in you, doesn't it? That the quietest things might shape the loudest destinies. That the emptiest rooms might be the ones most filled with unseen stories. You are lying in your own vacuum now, your own little space of darkness and warmth. But your mind is filled with the ripples of what might lie beyond. And though no one can see vacuum energy directly, we see its consequences written across the sky, in the accelerated expansion of galaxies, in the push that outpaces pull. And yet, there's a catch. When physicists calculate the expected vacuum energy from quantum theory, the numbers come out wrong. Not just a little wrong, catastrophically wrong. By their estimates, the vacuum energy should be so enormous that the universe would have torn itself apart before galaxies ever formed. And yet, here we are, breathing, dreaming, wondering. This is called the cosmological constant problem, one of the biggest mysteries in physics today. Why is the vacuum energy so small compared to what theory predicts? What balances it? What quiets it? No one knows. But the whisper remains, even in flawed equations, even in uncertainty. The vacuum still hums. You listen now, not for answers, but for echoes. You feel the stillness between your breaths, and the strange possibility that this quiet is not empty at all. And just as your thoughts begin to slow, you wonder something else. If every point in space is pregnant with energy, what other forces might be hiding there? What else Might the vacuum be trying to become? The story begins with a mind that reshaped time, a man who dared to bend the universe with thought. Einstein. You know his name as a symbol of brilliance, the wild hair, the chalkboard scribbles, the deep-set eyes, gazing into the abyss of space and reason. But tonight, you meet him not as a legend, but as a man who doubted himself, who added something to his equations, then wished it away. It was called the cosmological constant, lambda, single symbol in a sea of math meant to keep the universe still. You see, Einstein's equations, beautiful and brave, told him something he didn't expect, that space itself wanted to move, that gravity, when applied across the cosmos, would not hold things static. It would cause them to collapse or expand. But in 1917, telescopes were still blind to the universe's drift. The sky looked fixed, the stars eternal. So Einstein added a term to balance things, lambda, a push to cancel the pull, a cosmic counterweight, not because nature asked for it, but because human vision wasn't yet wide enough to see what space was doing. It was a patch, a placeholder, a reluctant invention from a man trying to steady the stars. And for a time, it worked. The cosmological constant kept the universe from collapsing in his equations. It held it steady on paper like a still pond in a windless world. But science, like the cosmos, refuses to stay still. In the 1920s, Edwin Hubble peered deeper into the velvet dark. He studied galaxies, their light stretched thin as if pulled by invisible hands. And what he saw shocked the world. The galaxies were not sitting still. They were fleeing, racing outward, riding a tide that no one had seen before. The universe was expanding, not slowly, not quietly, but with an urgency written in every spectrum of light. And suddenly, Einstein's constant looked like a mistake. Why add a force to hold space steady if the universe wasn't steady at all? He removed it, dismissed it, called it his greatest blunder. The term vanished from his equations. Lambda was left behind, like a forgotten note in the margin of a masterpiece. But the universe is patient, and sometimes blunders are just ideas arriving too early. Decades later, astronomers would look again at the farthest lights. They'd study supernovae, exploding stars that serve as beacons across billions of years. And what they found was not just expansion, but acceleration. The universe wasn't just drifting outward, it was speeding up, as if something unseen were pushing it. Not gravity, but anti-gravity. Not pull, but push. And suddenly, Einstein's constant came back. That quiet lambda returned to the front lines of physics, no longer a mistake, but a clue, a whisper from a time when we didn't yet know how restless space could be. And now we wonder, was lambda Einstein's regret? Or was it his premonition? You breathe in slowly, letting the thought settle. that even a discarded idea can become a doorway. That sometimes we draw a line on a blackboard and think it's wrong, when in truth, we are only too early to understand it. In modern cosmology, lambda lives again, this time as a possible name for dark energy, the unknown force driving cosmic acceleration. We don't know if they are the same, but it's tempting to believe that the thing Einstein once added to steady the stars might be the very thing tearing galaxies apart. There is symmetry in that strange kind of poetry. And tonight, as you lie still, you begin to see how even physics is full of revision, of humility, of second chances. We still use Einstein's equations, the Einstein field equations, to describe the curvature of space and time, and lambda remains an optional term. We can include it or not. We can try to fit it to the way galaxies behave, but we don't truly know where lambda comes from. Does it arise from the vacuum itself, that restless sea you met last night? Is it born of quantum fluctuations? Or is it something deeper still, woven into the fabric of space and time? Some see lambda as a constant. Others think it might evolve. What if dark energy isn't a fixed force, but a shifting presence? Tide that changes as the universe grows older? And if so, what does that mean for the end of everything? Will space keep expanding faster and faster until galaxies are too far to see each other? Will stars burn out in isolation, leaving only cold embers in an ocean of silence? This is the vision called the Big Freeze, a universe stretched thin by its own expansion, empty by the very force that once lit its fires. And in that far-off future, lambda would still be there, soft, invisible, relentless. You drift deeper now, cradled in the quiet power of equations and fate. You picture Einstein standing alone beneath a dome of stars, his chalk dusty, his thoughts vast. He could not see the galaxies fleeing. He could not hear the whisper of dark energy, but still his mind reached beyond the present. And even in his blunder, he left us a path to follow. Lambda, just one letter, but tonight it feels like a portal, a symbol of mystery, of humility, of how even the brightest minds can stumble toward something true. And as you begin to fall more deeply inward, your thoughts begin to ask if this constant shapes the expansion of space. Could it also shape the ultimate fate of everything? What does lambda want? What is space trying to become? Tonight, you lie quietly, held gently by the curve of your pillow, your breath slow, your thoughts fast. Above you, space is stretching, not rushing, but gliding, a silent unfolding of all things. You've learned about the strange constant, Einstein's lambda, that returned from exile to explain the restless speed of galaxies. But tonight, we drift deeper. We ask, what kind of pressure pulls instead of pushes? It sounds backward, doesn't it? We think of pressure as something that swells, presses out, balloons a balloon, tightens a seal, pushes steam through pipes. But this pressure, the pressure of dark energy, is not like that. It is a pressure that pulls, a reverse sigh, tension woven into the vacuum, subtle, persistent, and unlike anything you've ever felt. You are used to gravity pulling, to apples falling, planets circling, oceans rising and falling in moon-drawn tides. But gravity is tied to mass and energy, to things. Dark energy is tied to emptiness, and that emptiness, ironically, does not pull in the way gravity does. It pushes space to expand, and somehow that push behaves like a pull against gravity's embrace. Let's slow that down. In physics, energy and pressure are siblings. They live together in the equations of the cosmos, and dark energy has a kind of negative pressure. Imagine a trampoline. Usually, if you place something heavy at its center, the surface dips, pulling marbles inward. That's gravity. Now, imagine that instead of a weight, something invisible is pulling up from underneath the trampoline, stretching the fabric outward. That's dark energy. It doesn't add weight. It subtracts hold. It acts not like a rock, but like an unseen wind beneath space itself. Its pressure has no direction in the way we're used to. Instead, it fills space uniformly, not stronger here or weaker there, but the same everywhere. This is what we call isotropic pressure. No edge, no direction, no source, just a steady, silent tension in the fabric of existence. This pressure is what fuels the universe's acceleration. It doesn't come from stars or gas or heat. It comes from space, being space, from the vacuum not being empty. You feel the strangeness, don't you? We are taught to think of a vacuum as nothing. But the vacuum in modern physics is not void. It is alive with potential, with quantum hum, with fluctuations that rise and fall like tiny, invisible tides. Dark energy may be part of that, an echo of quantum fields that press outward with no origin, no shape, no mass. Its pressure is not born of force, but of expansion, and that expansion has consequences. It means galaxies move farther apart with time. It means the light from distant stars is redshifted, stretched like silk across space. It means the future is not gravitational collapse, but cosmic unraveling. The more space there is, the more room there is for this pressure to act. And so, the more it pulls. You might wonder, how strong is this pressure? Surprisingly, it's very weak, tiny, feather soft, but over cosmic distances and over billions of years, even the gentlest nudge becomes unstoppable. Dark energy is not a gale, it's a sigh that never ends. And that sigh is louder than gravity on the scale of galaxies. You shift beneath your blanket, And for a moment, you imagine yourself as part of that fabric, your atoms, once crowded in ancient stars, now floating in a universe that stretches around you like a sleeping lung, inhaling forever. There is a name for how we describe this pressure mathematically. It's called equation of state, a ratio between pressure and energy density. For dark energy, we call this ratio W, and for the simplest model, W equal -1. This negative number tells us that dark energy's pressure acts the opposite of what we expect. A pull that expands, a pressure that doesn't squeeze, but widens. No other known form of energy does this. Radiation doesn't. Matter doesn't. Only dark energy has this strange, backward signature. And that's how we recognize it. Not by what it is, but by what it does. A fingerprint left on the motion of the cosmos. And still, we do not know why it exists. Why would the vacuum have a pressure? Why should nothing stretch everything? You are not alone in asking. Cosmologists debate this in quiet rooms lit by simulations. Some believe this pressure is constant, a property of space that never changes. Others think it may vary, that it may decay, shift, or even reverse in a far-off age. What if dark energy turns off one day? What if the pressure weakens and the universe slows or collapses or rips apart? There are names for these possibilities: the big chill, the big rip, the big crunch, each a different ending shaped by the pressure of nothing. You're drifting now, held in the soft gravity of wonder. In your quiet room, you can almost hear the whisper of the vacuum expanding, a whisper made of no particles, no sound, no light, and yet it speaks volumes. It tells you that even nothingness has power, that even space can press, that even emptiness can shape fate. You begin to sense the rhythm of the cosmos, push and pull, dark and light, stillness and flow, all governed by quiet balances we cannot see but feel, in the way stars move, the way time stretches, the way we wonder. So as you breathe again, a little slower now, you ask, is dark energy the final breath of the universe? Or is it the first? Is this pressure a passing phase, or the heartbeat of space itself? Out beyond your window, where the stars hum silently and galaxies drift like lanterns on an invisible tide, there is a struggle, not a violent one, not with noise or swords or flame, but a gentle, ancient tug of war that defines everything. It is the softest pull, the subtlest shove, but it decides how the cosmos lives and how it may someday end. Tonight, you and I float together into this slow contest, the quiet competition between gravity and dark energy. Two invisible hands with opposite aims. One wants to bind, the other to loosen. One whispers, "Come closer." The other breathes, "Drift away." This is not mythology. This is the structure of space and time. It began in the very first instant when the universe was no older than a blink, no wider than a breath. In those first hot moments, gravity and expansion met each other like dancers testing the rhythm of creation. Gravity, born from matter and energy, wanted to clump. It tried to pull everything inward, to wrap the cosmos into a tighter ball, but the Big Bang had already sent things outward, like fireworks bursting from a single match head of existence. And the question ever since has been, who will win this slow race? For a long time, it seemed gravity had the edge. The early universe was dense, rich with matter, hot plasma, racing light, young elements learning to become stars. Galaxies were born from the folds of gravity's will. Stars formed in the arms of its embrace. Planets circled, moons clung. Your very body, curled now in stillness, is shaped by it. But gravity's strength is tied to mass, and as space expands, the mass thins. Imagine stretching taffy until it grows so long it can barely hold together. The more the universe grows, the more its matter spreads thin. Gravity's grip weakens, and in that softening, something else awakens. Dark energy, that strange, pulling pressure woven into the vacuum of space itself. It does not dilute as matter does. Its strength does not fade as galaxies scatter. Instead, it stays constant, always there, always stretching, unbothered by distance or time. And so, a turning point came. Billions of years after the Big Bang, the universe reached a delicate balance. Gravity had slowed the expansion for eons, but then, like a thread, suddenly tugged tighter, dark energy began to dominate. It was as if the universe exhaled, long and slow, and found that nothing held it back anymore. The expansion began to accelerate. This is the moment we live in now. Universe in gentle tension. The cosmos in contest. Galaxies drift away from one another, not just because of ancient momentum, but because of something still pushing. We are caught in this tug of war, though we do not feel it in our daily lives. Your feet remain on the ground. The moon still tugs at the tides. The earth holds you in its orbit, but across the cosmic scale, between clusters of galaxies, the expansion is pulling stronger than gravity combined. And so, structures that are not yet formed will never form. Galaxies not yet neighbors will never meet. The universe is writing its future through this competition, and the outcome depends on balance. Cosmologists speak of a critical density, the tipping point between a universe that recollapses and one that expands forever. Add too much matter, and gravity wins. The universe folds back on itself in a fiery crunch. Add too much dark energy, and expansion wins. Galaxies vanish over each other's horizons, and stars die in growing solitude. But we appear to be in the middle, or just past it. Our universe seems flat, neither curving in like a sphere nor opening out like a saddle. Flatness means balance, but balance, in this case, is delicate, too delicate to last forever. Dark energy, gently, persistently, is winning. And so, we peer ahead. What will this tug of war lead to? Some predict the big freeze, a future where galaxies become so distant their light never reaches us again, where stars burn out one by one, leaving behind a darkness ever expanding. Others wonder about the Big Rip, a scenario where dark energy grows stronger and even galaxies, stars, planets, molecules, atoms are torn apart by its pull. Each fate is shaped by the balance of forces we explore tonight. And yet, within this vast battle, something quiet endures. The beauty of the in-between. You, alive now, in the tender pause between gravity's past and expansion's future. Your life takes place in the golden age of galaxies, when stars still shine, when cosmic light still crosses the skies, when the tug of war is still visible in the patterns of supernovae, the movements of clusters, the background glow of the cosmos. You are here in the breath between poles. The balance is not permanent, but it is real, and it allows you to look up and wonder, to measure the faint redshift of ancient galaxies, to feel the soft echo of the Big Bang's light in microwave whispers, to imagine the future as something unfolding from this moment where neither side has won completely, not yet. So you close your eyes and picture the two hands, gravity, the binder of stars, the sculptor of form, the hug of all things massive, and dark energy, the unstopping breath, the soft expansion, the stillness that grows larger than gravity's grasp. They do not fight with hatred. They do not destroy. They shape together. They compose the rhythm of everything. And in that rhythm, you fall gently, thoughtfully, into a kind of peace. Because you are not separate from this tug of war. You are made of it. And as the balance shifts, you find yourself wondering if dark energy is the wind and gravity the anchor, then what is time? What is time in a universe whose stretch keeps changing? Out in the dark, where galaxies breathe and stars blink across the black velvet sky, a certain kind of star dies loudly, not with a whisper, but with a brilliance that could outshine an entire galaxy. Supernova, the final cry of a heavy star, marks the end of a stellar life. And yet, in that ending, it becomes a lantern, a measuring stick for space itself. Candle held up against the ever-expanding dark. Tonight, you drift closer to these dying lights, not to mourn them, but to listen to what they teach about distance, about time, about the silent swell of the universe. There was a time when the cosmos seemed too vast to measure. You see, without a shoreline, a blackness too deep for rulers too wide for fingers to span. But astronomers, like careful dreamers, began searching for candles in the dark, lights whose glow they could trust. And in supernovae, they found one. Not just any kind, special kind, typia. Stars that die, not from loneliness, but from companionship. You see, these are not lone giants. They are white dwarfs, the smoldering cores of stars long past their prime. And they live in quiet orbit with another star. They draw material from their partner bit by bit, growing heavier, silently, until they reach a threshold. And then, in a flash, they explode. But here's the wonder. They all explode in nearly the same way. The same mass, the same fury, the same brilliance. They become what astronomers call standard candles, like identical bulbs placed at different distances. You can tell how far one is by how dim it looks. The farther the supernova, the fainter its glow. So by comparing what we see to what we know they should be, we can measure space itself. Imagine that, measuring the shape of the universe with the afterglow of dying stars. It was in the 1990s that two teams, quietly racing across observatories and across continents, began to map these cosmic flares. They studied hundreds of type Ia supernovae, catching their light with careful eyes. And what they found was not what they expected. They thought the universe's expansion was slowing down because gravity, surely, was pulling things back in. But no, the supernovae were dimmer than they should have been, fainter, farther away, which meant they had moved farther than expected, which meant the universe wasn't slowing. It was speeding up. A quiet gasp ran through the cosmos that day. Acceleration, expansion, that doesn't ease, but grows faster with time. Was as if space had let go of its own brakes, as if something unseen were pushing outward with increasing strength. That something would come to be called dark energy, and those faint flickers, those dying stars, had revealed it. Think of the poetry in that. In death, they offered clarity. In their silence, they mapped the invisible push of the universe's breath. Supernovae became shadows cast in motion. Their fading light traced the curvature of time itself. And still today, astronomers chase them. Orbiting telescopes like the Hubble have stared deep into the past, catching light that began its journey billions of years ago. Each supernova is a messenger, a whisper from a younger universe. You imagine it, the flare, the bloom of light, the slow fading as the expanding universe carries it away. And still, that light finds you across vacuum, across eons. So you close your eyes and let the story unfold. You are holding a match, tiny and glowing. If it's close, it burns your vision. If it's far, you can barely see it. Now imagine placing 1,000 matches across the desert of space, all lit, all the same brightness. You step back and look. Some are dim, some brighter. And with each flicker, you learn more about the terrain between you and the flame. That's what scientists do with supernovae. They chart the terrain of spacetime using light's memory, but even more, they trace how fast the terrain is changing. And that's where the mystery grows deeper, because the expansion does not proceed with gentle rhythm. It accelerates. Something we can't see is pushing harder with time. But what is that force? Where does it come from? And why now? This puzzle, this ghost of motion, echoes through every supernova we observe. Some theories say it's a property of space itself. Others imagine a dynamic field, like a tide, rolling through the cosmos. But so far, every answer has only led to more shadows. The light tells us something's wrong, or perhaps just incomplete. And in that incompleteness, you find wonder, because we are still learning to read the sky, still learning to measure the universe by the way it carries light. You, too, are made of stars, and yet you measure their distance from your quiet bed. You trace their final flashes with tools built by human hands, yet powered by ancient questions. We are far from those supernovae, but not far from their meaning. They show us the universe changes in ways we never guessed, that motion can hide a mystery, that dying stars can teach us how to live with questions. The sky, even in its vastness, can be mapped by patient eyes, but only if we listen to the flicker, only if we measure the shadows, only if we trust that light, even fading, still carries truth. And so, with each new flare caught in a telescope's eye, we are reminded to learn about the universe. We must watch how it lets go, not just how it holds. And that brings us softly to our next question. If light tells us how fast space is expanding, can the universe itself change what it's made of? You lie still as the sky folds inward, not with noise, but with a silence that carries questions too large to hold. Above you, space is not a stage, not empty, not still. It breathes like an animal dreaming. It stretches like cloth pulled over time. It curves, it slips, it warps beneath things with weight. And perhaps, strangest of all, it vanishes. Tonight, you drift into the idea that the very fabric of the cosmos may not be permanent, that what holds us, guides us, shapes us, might someday fade away. To understand this, you must first understand that space is not a fixed background. Einstein showed us that. He said, mass tells space how to bend, and space tells mass how to move. The universe, then, is not floating in space. It is space, changing, evolving, shaped by what's inside it. Galaxies do not fly through emptiness. They ride a swelling tide. And that tide, the expansion of space itself, has its own secrets. You remember from last night, the supernovae showed us that the universe's growth is speeding up. Something is pushing, not gravity pulling in, but a pressure pulling out. We called it dark energy. We gave it a name before we understood it. But tonight, you wonder more deeply. What if that energy is not just a force within space? What if it is space? And what if space isn't as solid as we once believed? Physicists have tried to capture this mystery in numbers, and the numbers, in quiet rebellion, refuse to behave. There is something called the cosmological constant, a value Einstein once added to his equations to keep the universe still. Later, he called it a mistake. But now, we've had to revive it to account for the accelerating universe. Still, when quantum physicists try to calculate the energy of the vacuum, the nothingness of space, they get an answer so large it defies imagination. 100 zeros in the wrong direction. Discrepancy between theory and observation that suggests something is deeply wrong with how we understand the void. You pause here. What do we mean by void? What is empty space? Not truly empty. Even in the quietest corner, particles flicker in and out. Virtual pairs appearing and vanishing in quantum breath. The vacuum, as it turns out, is not a flat stillness. It is a storm beneath the calm. It seethes with possibility, and it may be that this sea is not stable. Imagine a landscape made of ice, solid, still, but not unchanging. Because if just enough warmth slips in, the ice melts. The whole structure alters its shape, its rules, its way of being. Some scientists believe our universe is like that the vacuum we live in is not the true lowest state, not the final floor, but a plateau, a local calm in a wider chaos, a false vacuum, stable for now, but only just. And if it were to decay, if the vacuum shifted to a lower state, everything would change. The laws of physics, as we know them, could vanish. Particles could gain or lose mass. Forces could collapse or reverse. Atoms would no longer hold. Light could bend in unfamiliar ways. And the shift, they say, would come not with fire, but with silence. A bubble of new reality expanding at light speed. A phase change of the cosmos. No warning, no escape. But don't be afraid, because this idea, this vacuum decay, is a theory. Thought built from numbers that don't yet agree. And even if true, the timescale is vast, longer than stars live, longer than galaxies breathe, longer than worry can reach. Still, the idea lingers that space itself might not last, that the stage might fold, that the fabric we trust beneath us might be woven of impermanence. And there's something quietly beautiful in that, because it means even the vastest things are not immune to change. Even the infinite has vulnerability. You imagine it now. Space as a sheet fluttering in a cosmic breeze. It stretches with galaxies sewn into it. It curves where black holes sit. It thins where dark energy pushes. And somewhere, deep beneath its visible threads, there is a tension not yet understood. a potential to become something else. Physicists search for ways to test this. Some peer into high-energy collisions, hoping to glimpse a flicker of vacuum instability. Others stare at the cosmic microwave background, the leftover light from the Big Bang, looking for clues in the oldest photons. But the vacuum does not give up its secrets easily. It shimmers, it hides, it slips away when you try to hold it. And maybe that's the lesson, that the foundation of the universe is not firm, that creation rests on a surface always in motion. But you are here, you who float on this invisible sea, you who measure its currents with light from distant stars. You rest in the arms of a cosmos that evolves, not like a machine, not with gears, but like a thought still forming, like a fabric that shifts with every question you dare to ask. And as you drift between certainty and wonder, a final thought begins to form. If space can change, if the vacuum is unstable, if even nothing is not truly nothing, then what is the true nature of emptiness? You rest beneath a sky woven with stars, each one a pinprick in the fabric of time. But tonight, we look past the stars, beyond the galaxies, beyond the clouds of dust and trails of light, toward the faintest whisper the universe has ever left behind, an echo still rippling through the silence, a glow not from a star, but from a time before stars were born. The cosmic microwave background. You've heard of it, perhaps, the leftover light from the beginning. But what does it mean for something to echo for 13.8 billion years? And how can silence hold memory? Let's drift back now, further, further still, past the Milky Way's arms, past quasars and radio bursts, past the first galaxies, just learning how to spin. We reach a wall, a fog, soft and glowing, a veil of heat, frozen in time. This is the moment when the universe cooled just enough for light to roam free. Before that, space was too dense, a hot, brilliant plasma of particles and photons locked together in collision. Light couldn't travel far. It scattered, bounced, dissolved into heat. But then, roughly 380,000 years after the Big Bang, the universe cooled. Atoms formed. Electrons settled into place. The fog lifted. And the first light was released. Not the light of stars. Not yet. This was the light of becoming. The light of a universe clearing its throat to speak. And it still travels. It has stretched and cooled, but it has never stopped moving. We call it the cosmic microwave background, or CMB, not because it's loud, not because it shines bright, but because it's everywhere. Even now, as you lie still, that light passes through you. A sea of ancient photons, chilled now to just a few degrees above absolute zero, still whispers around your skin. It is in every direction, a perfect background hum, a cradle song of the cosmos itself. And yet, this faint glow, holds astonishing detail. Because when scientists mapped it using satellites with delicate eyes, they saw something unexpected. Not uniformity, not smooth light, but tiny fluctuations, ripples, warm spots, cool patches, like the wrinkles in a baby's blanket. Those slight differences, only a fraction of a degree, were the seeds from which all structure grew. Every galaxy, every cluster, every planet, every star, each one can trace its ancestry to those soft imprints in the microwave sky. You pause here. Let that sink in. The reason stars sparkle, the reason planets spin, the reason you are here at all is because of faint, ancient wrinkles in a field of invisible fire. This background radiation is not just a leftover. It is a time capsule, a snapshot of the baby universe, captured not in light, but in memory. And the story it tells is one of wild beginnings. When the CMB was discovered, almost by accident, in the 1960s, the idea of a Big Bang shifted from theory to echo. Two radio engineers, Penzias and Wilson, heard a strange hiss in their antenna. No matter where they pointed it, the noise remained. They tried everything, removed bird droppings, checked the electronics, but the hiss persisted. What they had found was not a fault. It was the past, a universal glow from a time when the universe was less than 500,000 years old. And we have listened ever since. Each time we measure the CMB, we learn more about the shape of space, the amount of dark matter, the signature of inflation, the gentle tug of dark energy, even the geometry of the cosmos. Whether space is curved or flat can be read in those ancient whispers. And here's a wonder. It is remarkably flat, not curved inward like a sphere, not bent outward like a saddle, but flat. This tells us something extraordinary, that the early universe must have expanded in a flash. Cosmic inflation, they call it. An unimaginably fast swelling of space itself within the tiniest fraction of the first second, not exploding like a firework, but stretching like dough pulled from all sides. This inflation smoothed out the wrinkles, but left enough to shape the future. And the CMB preserves that moment. Like frost on glass, it captures the breath of the beginning. But it also leaves questions unanswered. Why did inflation start? What set it in motion? What existed before? Did anything? Or does the question no longer apply in a world where time itself was born alongside space? You breathe. You let the questions drift through your thoughts without needing answers. Not yet. Because the beauty here is not in the certainty. It is in the shimmer of not knowing. You lie beneath this sky, and though your eyes see only stars, your mind now holds the memory of light from a time before starlight began. Soft echo, still glowing, still moving, still whispering, the earliest truth the universe ever spoke. And as you listen, not with your ears, but with your wonder, you begin to feel a shift, a pull toward something deeper still. Because if echoes remain, If light can travel for billions of years to find your skin, what other signals might have survived? What other relics float in the silence, waiting to be found? You imagine the universe like a great balloon, a silver sphere swelling gently in the stillness of night. And you wonder, where does it end? Is there a place where stars stop spinning, where galaxies fall silent, where the velvet of space simply ends? Tonight, you drift with that question. You lie still, but your thoughts roam far, beyond the edge of Earth's warmth, beyond the shimmer of our sun, past the swirl of the Milky Way, and into the vastness where space itself stretches. But the deeper you go, the stranger it becomes. Because what if there is no edge at all? What if the universe has no boundary, only a continuous fabric curving upon itself, like a whisper that never ends? This is not easy to imagine. Your mind wants corners, borders, walls. It wants to walk to the end of the road and look beyond. But space is not a road. It is not a balloon sitting inside something larger. It is all there is, and it may loop without needing an outside. Some call it finite, but unbounded, a strange phrase. But it means this: you could travel forever without ever hitting a wall, like walking across the surface of a globe. You can keep going, circle the sphere, endlessly move, and yet you never find an edge. That's the wonder of curved space. In the early universe, shape mattered deeply. Was it open like a saddle, closed like a sphere, or flat like an infinite plane? Scientists asked this as they studied the cosmic microwave background, that ancient afterglow still cooling around you. And the answer came gently, not screamed in numbers, but whispered in temperature. The universe, it seems, is almost perfectly flat, not curved inward or outward in any strong way. But what does that mean for you? If space is flat, it could still be infinite, stretching endlessly in every direction. Or it might be like a video game screen, where traveling too far in one direction brings you back to where you started, looping silently through dimensions your senses cannot touch. In either case, there is no wall, no edge, no final shell, only the strange, endless whisper of space expanding around itself. And it's still expanding. That's the other part of this mystery. You are not only inside space, you are inside movement. Galaxies are drifting apart, not through space, but because space itself is growing between them. It's like the surface of a raisin bread, baking slowly, each raisin pulled farther from its neighbors as the dough swells. But you are not a raisin. You are made of stardust, and your mind reaches far beyond crust or sky. You ask, how can everything move away from everything without a center? And the truth is more dreamlike than logical. In cosmic terms, there is no center, no special point where the universe began. Every point is equally valid. Every location sees other galaxies moving away just the same, because expansion is not happening in space, it is space. The very fabric of reality is stretching in all directions at once. So you, sitting here on this small planet, are as much in the center as any galaxy, 10 billion light years away. There is no preferred seat, no privileged corner, only participation. You are part of this unfolding. And yet, as you breathe beneath stars, you may still feel a gentle loneliness. Because if space goes on forever, or folds in ways we cannot trace, what lies beyond what we can see? Is there more universe past the cosmic horizon? A place too distant for light to reach us, even across billions of years? Scientists believe the observable universe is just a small bubble within a potentially vast, perhaps infinite, cosmic sea. What we see is defined not by the edge of space, but by the edge of time, the time light has had to reach us since the beginning. Beyond that edge, there may be more galaxies, more stars, entire structures we will never witness. Not because they're hidden, but because they're out of reach, forever beyond our line of sight. And that horizon, like the ocean's rim, moves with us as we sail through time. You might ask, if we can't ever see them, do they truly exist? And the universe answers quietly, yes. Existence does not require your eyes. It simply is, like the part of a dream you can't recall, but still shaped the way you woke. Still, some scientists explore models even stranger. Ideas of multiverses, where our universe is one bubble among countless others, each expanding in its own space, with its own rules, its own constants, its own physics. In some, stars may never form. In others, atoms may not exist. And in some that feel eerily familiar, there may be a version of you asking these same questions beneath another sky. But tonight, you don't need many worlds. Just this one. Just this quiet truth that you live in a universe with no edge, that you are held in an endless unfolding, a shape without borders, a breath without wall, and your body, as it rests, carries within it the same atoms that drifted through those first spaces. No place to fall, no cliff to cross, only continuity and the gentle realization that your existence has no clean border either. Your thoughts, your feelings, your memories, they ripple out into others. You expand like space expands, without edges, without end. As your breath slows and your thoughts begin to soften, a new question stirs in the vastness of your mind. If space has no edge, and you are part of space, then is there any true boundary between you and the cosmos? Or are you, in some quiet, infinitesimal way, the universe experiencing itself? Tonight, you rest beneath a sky that is always moving. It feels still to your eyes, but the stars, they drift quietly, inevitably, like thoughts dissolving into memory. You lie back, breathing in the hush of a sleeping world, and wonder, where is this all going? The galaxies, so grand, so glowing, do not stay fixed. They are not frozen jewels, pinned to some celestial dome. They are wanderers, riding the current of cosmic expansion. and they are drifting away. Every moment, the light from distant galaxies stretches a little more, not because the galaxies move through space, but because space itself is growing between them. Imagine tiny lanterns floating in a great black sea, and imagine the sea slowly swelling. The water stretches, carrying each light farther from the next, not by push or pull, but by expansion. That is the fate you live within. The stars, those ancient storytellers, are not eternal. They are born, they burn, they exhaust. And galaxies, though vast, have lifespans too, not days or years, but epochs, billions of years. From now, the stars we see will flicker out, their fuel spent, their fire done. And slowly, galaxy by galaxy, the night will grow darker. This is not sadness. It is a rhythm, a cosmic rhythm, written into the structure of everything. In the early universe, galaxies were closer. There was more hydrogen, more collisions, more creation. Stars were born in rapid bursts, blue, massive, short-lived giants. But even then, entropy was waiting. Entropy, that quiet law of disorder, that ticking of the universal clock. It does not break things. It lets them unfold. It lets fire consume what is bright until only embers remain. One by one, the stars will dim, the galaxies will quiet, and the universe will slide into what scientists call the heat death, a state where everything is so evenly spread, so low in usable energy, that no work, no motion, no life can stir. Not heat, but uniform cold, a hush that cannot be undone. But this is not the only fate ever imagined. There was once the thought of the big crunch, that gravity would someday pull all things back in. Galaxies reversing course, falling together, collapsing inward into fire and singularity, the opposite of the bang that began it. Others dreamed of a big bounce, a cycle of bang and crunch, bang and crunch, endless rebirth through cosmic breath. But now you drift in an era where another story seems more likely. It is the tale of a universe accelerating outward, faster, farther, unstoppably, not slowing toward return, but speeding into loneliness. The stars drift faster, the light redshifts longer, and the distance between galaxies grows so great that someday each one will disappear from the other's view. The night sky will fade, not because the stars are gone, but because their light can no longer catch up. We will live, one day, in cosmic islands, galaxies adrift, cut off by the stretching of the universe's skin. This, too, is part of the fate written in the stars' drift. But here is the gentle secret. You are here in the golden time, the moment when light still reaches, when galaxies still whisper to one another across the dark, when the stars still sing their thermonuclear lullabies, and we, their listeners, still understand the language of light. You are part of the chapter that knows the story of beginnings, not because you saw them, but because the cosmos left echoes in every red-shifted beam, in every flicker of dying starlight. The universe tells you where it is going and where it's been. Astronomers look deep into this story with instruments like time machines. They read the light of Type Ia supernovae, stellar explosions, so uniform they serve as cosmic yardsticks. From their brightness and how much their light stretches, we know the universe isn't just expanding, it's accelerating. Some quiet, unseen force is driving galaxies apart faster and faster. We call it dark energy, but we do not understand it. Not yet. It is the wind beneath reality's surface, pushing on the fabric of space-time, and in its quiet pressure, the fate of the stars is sealed. You imagine the final stars, red dwarfs, burning low and long. They may live trillions of years, and when they fade, there will be only remnants. White dwarfs, neutron stars, black holes, dead things drifting in expanding dark. Eventually, even those will dissolve. Black holes may evaporate through Hawking radiation, leaking particles into space so slowly it takes eons, until, at last, the last light goes out and the universe becomes an endless sea of thin, cold nothing. That's one version, a quiet ending, a stretched silence. But even this silence carries beauty. It is the quiet after a symphony. It is the breath between dreams. Because meaning doesn't require permanence. It comes from now, from presence, from the fact that you exist in this luminous moment, this short, golden span, when stars still shine and galaxies still dance. You, a thinking being made of the universe itself, are witness to the sky's great unfolding. And perhaps that's enough. The drift of stars is not a tragedy. It is a message. It says, nothing is still. All things change, even light, even time. And yet, amid that change, you have this breath, this heartbeat, this glimpse of cosmic truth painted across the night sky. Let it remind you that all stories end, but the telling of them is joy. And as the stars keep drifting, pulling away in silence, a question stirs just beneath your rest. If all of this moves outward forever, what becomes of time when the stars are gone? Somewhere deep in the whispering dark, beneath the hush of starlight, long gone, a force breathes without a face. It is not wind, not gravity, not anything you can touch, but it moves things nonetheless. Tonight, as you settle into silence, know this: the universe you lie within may not be pulled by something fixed, but by something that evolves. This is the idea of quintessence, a phantom force, a changing energy that may one day slow its pull or strengthen it beyond return. In the ancient days before modern physics, quintessence meant the fifth element, the pure, heavenly stuff that made up the stars, the divine breath of the cosmos. But now it has returned in another form. a ghost in the equations, a variable pressure woven through time, not constant, like Einstein's forgotten lambda, but living, shifting, quintessence, not a particle, not a wave, a field, a slow-moving ocean beneath the surface of space-time itself. Imagine, if you will, a tide, not of water, but of potential. It flows between galaxies, nudging them apart. But unlike a steady wind, its strength can grow or wane. It may have started as a whisper, but in distant futures, it could roar. Physicists don't know what it is made of, only what it does. They use the math to listen for its breath, to ask the question no telescope can see. What if dark energy changes? The current picture, the CDM model, says dark energy is constant, that it always pulls with the same softness, the same calm. But if it's quintessence, then the universe may not be headed for the quiet fade we've imagined. It may veer, spiral, twist, and everything we thought was written may be rewritten. If quintessence is real, it behaves like a fluid with negative pressure, a strange, reverse kind of tension that makes the universe stretch instead of contract. But unlike a cosmological constant, this pressure can shift, like a mood, like a breath held too long. And if it grows stronger over time, well, the consequences could be shattering. This is the realm of the Big Rip. It sounds like myth, but it emerges from the math of changing dark energy. If the repulsive force of quintessence increases faster than expected, then one day it will overcome gravity, even within galaxies, even within atoms. First, galaxy clusters will dissolve, then galaxies themselves will scatter. Then, stars will be torn from their orbits, then planets from their stars, then moons from planets, and then molecules from molecules, atoms from atoms, until space-time itself rips open into something we cannot imagine, all in silence, all as a consequence of a field that simply changed too much. But not yet, not now, tonight. You are safe in the slow drift of what may still be a quiet fade. Still, the mystery remains. What is this force that pushes the stars apart? Is it truly constant, or is it alive in some unknowable way? The clues may lie in the past. If we can map how galaxies used to drift, how supernovae used to shine, we can compare those echoes to now. It's like listening for a heartbeat in the sky. Faint, but there. If it speeds up, we'll know. If it slows, we'll know. And in those changes, we glimpse our future. If quintessence is real, it may have come from the earliest moments of the universe, just after inflation, when space itself was expanding faster than light. In that primordial hush, fields jostled, shifted, and settled. Some faded, some froze, but maybe one stayed alive, soft, subtle, waiting, a latent energy that would awaken billions of years later, just as gravity began to loosen its grip. You might picture it like a sleeping dragon, dormant beneath the cosmos, waking slowly into power, or like a vine growing across the fabric of space-time, gently tugging it outward. It's not malevolent, not kind, just present, just real. It has no face, no name, only a pressure, only a presence. We've never seen it directly, but it leaves fingerprints in the bending of light, in the shifting of galaxies, in the afterglow of the Big Bang. Quintessence is possibility, a whisper of something not yet understood. And like all good mysteries, it asks questions, even in its silence. Why now? Why is this force so gentle that it only began to dominate the universe after billions of years? Why not sooner? Why not never? It is the cosmic coincidence problem, the unsettling notion that we exist precisely at the moment when dark energy rises to power. It is as if we are living in the turning of a page, the moment when one era fades and another begins. Perhaps the answer lies in physics we have not yet found. Perhaps it lies in dimensions we do not yet see. Or perhaps, as some speculate, quintessence is tied to the fate of consciousness itself, that in the long arc of cosmic evolution, the emergence of life and the awakening of universal expansion are linked in ways we cannot grasp. Tonight, as you drift in thought, know this: the stars may be fading, the galaxies may be scattering, but your awareness, here now, is part of the universe, trying to understand its own unfolding. You are not apart from this change. You are within it. You are made of atoms that once burned in stars, that once danced through galaxies, that are now drifting apart. And above you, beyond the clouds, beyond the dark, that pressure still pulls, changing or not, watching or not, phantom with no face, but endless consequence. And just beneath that mystery comes the next quiet question. What if the laws we trust are not constant at all, out beyond the hills of your sleeping thoughts, beyond the ticking of clocks and the hush of your breath? The universe unfolds, not in silence, not in fury, but in motion so vast that it can feel like stillness. You lie here, head against the pillow of the present, and everything around you feels steady. The room is still, the earth firm, the stars above fixed, but it is an illusion, a beautiful, comforting lie woven by scale and slowness. For nothing is truly still, not your heartbeat, not the earth circling the sun, not the galaxies slipping through the dark, and not the very constants that define our reality. Tonight, we ask a quiet question, not to disturb your rest, but to guide your dreams. What if the most sacred values in physics are not fixed, but drifting? Constants. They sound so certain, don't they? The speed of light, the strength of gravity, the charge of an electron, the fine structure constant, that mysterious ratio that controls the dance of atoms, the shimmer of light. These numbers form the skeleton of the laws we live by. They are baked into equations that describe stars, quarks, planets, and people. But some physicists, those who listen most closely to the hum beneath the cosmos, have begun to wonder, what if these constants aren't? What if they shift? Not by much. Just a breath, just a whisper over billions of years. The kind of drift you wouldn't notice in 1,000 lifetimes, but which might matter across the age of the universe. Imagine a violin tuned perfectly. Then imagine the pegs slipping ever so slightly over time. The notes bend, the harmony frays. But unless you listen for centuries, you might never hear the change. This is the whisper beneath the illusion of stillness. It began with light from distant quasars, beams that traveled across time to reach our telescopes. Encoded in that light were the fingerprints of atoms, absorbing it long ago. But something didn't quite match. The fingerprints, the spectral lines, were ever so slightly shifted and different from what we see in labs on Earth. A hint, perhaps, that the fine structure constant, which controls how electrons cling to nuclei and how atoms speak with light, might have changed over cosmic time. The evidence is not certain. It is delicate, contested, but it opened a door. What if the universe isn't governed by one eternal rule book, but by a rule book that rewrites itself slowly with time? This would mean that physics is more like a language than a law, a dialect that evolves. And if so, we are living in a verse whose grammar may be shifting even now. Consider this. The gravitational constant, G, determines how mass pulls on mass. It shapes the orbits of moons, the lives of stars, the expansion of the cosmos. If G were slightly stronger in the early universe, stars might burn faster. Galaxies might never form. If it were weaker, matter might never clump. No stars, no planets, no us. So if G has changed even a little, then the universe itself is not just evolving in shape, but in essence. Some theories go further still. String theory, with its extra dimensions tucked into invisibility, suggests that constants may be the echoes of how those tiny dimensions are curled. If they change shape, even minutely, then the values we see in our three-dimensional world could shift too. It's like shadows dancing on the wall. You see the shape, but the source may be turning somewhere unseen. And here's the thought that stirs like wind through tall grass. What if the laws of physics are local, not in space, but in time? What if the universe has epochs, like seasons, each with its own constants, its own symphony of rules? Perhaps the constants we measure now are true only for this cosmic moment, and in the far past or in far futures, reality hums a different tune. That would mean we live in a temporary truth, a truth that fits us perfectly, like a tailored suit, because we are shaped by it. We evolved in a universe where atoms form, where water flows, where light behaves, just so. But change the constants just a little, and the stars might not shine. The chemistry of life might not unfold. The very fabric of matter might unravel. It is a gentle reminder of how lucky we are, how finely tuned the symphony is. And if the tuning is not fixed, but drifting, then we are passengers on a moving song, sailing through harmonies that once were and may never be again. This doesn't unsettle, it soothes, because it reminds you that the stillness you feel is not the absence of motion, but the grace of balance in change. The earth spins beneath you, the galaxy turns, the constants may drift, but here, in this moment, everything aligns just enough to let you wonder, just enough to let you rest. And in the shadows of this thought, a deeper mystery rises, softly, like a tide beneath stars. If the constants of physics can change, could consciousness itself be part of what holds them in place? You float again tonight, as if on a quiet tide that has no shore, only depth, only dark velvet skies, threaded with light from long ago. Above you, the stars blink, steady in their twinkle, as though nothing moves at all. But this night, you will hear what lies beneath that hush, a slow current, a deep and ceaseless drift, the motion of galaxies through the vastness, like islands sailing on a sea with no edge. Galaxies, those great cities of stars, billions of suns spinning around a luminous heart, sometimes calm, sometimes violent, dusty arms curling like smoke in wind, like petals in eternal bloom. You live inside one, the Milky Way, a spiral of stars that spins in patience. It turns once every 230 million years, a time so large, so gentle, you feel no motion at all. But look from afar, from beyond this corner of the cosmos, and you'd see it drifting, not standing still, not anchored. No cosmic tree to tie it to, no pole or tether. Just motion, pure and free. Galaxies are not frozen into the fabric of space. They surf it. They are passengers on expanding tides, and space, that quiet, invisible medium, stretches slowly, steadily. Imagine dots drawn on a balloon. When you blow it up, the dots move apart, not because they crawl, but because the surface beneath them swells. So too with galaxies. They drift apart, not because they fly, but because the space between them grows. That is expansion, not like wind, not like explosion, but like breath, the breath of a cosmos still unfolding. And this drifting is not calm, not in scale. Every second, space expands, light stretches, distances widen. The Andromeda Galaxy, our nearest large neighbor, moves toward us still, pulled by gravity, but most others are sailing away, faster the farther they are. We see them recede in the redshift of their light, like sirens falling away in pitch, like farewells written in color. Each distant galaxy, a memory, a page from a book still being written, and yet already drifting out of reach. In this expansion, time and space are not stage and actors, they are partners. Space expands and time stretches with it. And so galaxies become more than just clusters of stars. They become markers, floating buoys on an ocean whose shores we may never reach. Their drift tells us the story of the universe, its age, its shape, its fate. Some galaxies are locked together in dances, local clusters, bound by gravity's tug, like flocks of birds or whirlpools in a river. Others are lost to distance, so far that no message we send could ever catch them. Because expansion outpaces even light over vast scales, there will come a time, billions of years hence, when many of the galaxies we now see will vanish from view, not because they die, but because the light they send will never reach us again. The space between us will grow too fast. We will become, in some future, lonely watchers in an empty sky, our galaxy and its neighbors still visible, but the rest of the cosmos will fade like dreams, forgotten on waking. This thought might seem sorrowful, but it holds a strange beauty. You are living in a precious moment, a brief window in cosmic history when the sky is full of galaxies, and you can still read the story of the beginning in their light. This is the moment when the universe is young enough to be seen, but old enough to hold secrets. A time when drifting islands still wave from across the dark sea. And so we measure them. We chart their speed, their motion, their color. We use them to trace the curves of space, to weigh the dark matter that binds them, to feel a push of dark energy that separates them. In their movement, we learn what the universe is made of, what forces tug it, what direction it sails. Galaxies are not just islands. They are clocks. They are compasses. They are fossils of a cosmos always in motion. Even our own galaxy is not fixed. It moves at nearly 600 kilometers per second through the cosmic background, not aimless, but caught in the pull of unseen mass, of nearby clusters, of the great attractor, a region of space so massive its name is a whisper. Ah, you feel none of this, and yet you ride it always. Your bed, your breath, your thoughts, all caught in this slow, majestic drift in a universe without up or down, without edge or center. Motion itself is relative, and so the galaxies teach us this, that stillness is just a slower kind of falling, that islands can float without anchor, that direction is measured in the difference between stars. And as you drift into sleep, the thought remains. You are not still. You are not lost. You are carried gently on tides older than light. And in the quiet of that motion, another wonder rises. If galaxies are drifting, what then? Is the sea they float upon? Tonight, your breath slows again as you settle into the silence between stars. You are not falling, and yet you move, carried not by wind, not by gravity, but by something stranger, something softer, yet deeper than all. In the last chapter, you drifted with galaxies, like islands at sea, each one receding further and further, not by its own effort, but because the sea beneath it swells. Now we look closer at that sea itself, the ocean of space and time, the thing that pushes and stretches, and the whisper that may be guiding it. We call it dark energy. But what is it? This gentle tyrant, this pressure with no touch. Imagine it this way. You place marbles on a soft, stretchy cloth. You press down, watch them roll toward the dip. Gravity. You understand that well. Now imagine the cloth begins to stretch outward on its own, without your hand. No pull, no push, just expansion from the fabric itself. The marbles slide apart, but not because they're repelling, because the cloth is growing. Between them, that's what dark energy does. It doesn't pull, it doesn't push, it simply makes more room, not faster than light, but faster than understanding. Pressure that pulls, a quiet force that causes acceleration, not by adding energy, but by allowing space to make more of itself. And so galaxies drift, not due to momentum, but because dark energy is always there, always stretching. Well, what if it's not always the same? What if this mysterious force could flicker, could fade, could wink? Not all at once, not like a candle, but like a tide that slows, or quickens, or vanishes for a breath before returning. Scientists call this a dynamic dark energy. The old name for it was a constant, Einstein's constant, single number woven into the math. But what if it isn't constant at all? What if the force shaping our future is changing beneath us? Imagine walking on a vast sheet of ice. You feel steady, but you can't see the current beneath, the slow river of temperature, of pressure, of hidden tides. You only see the drift of the ice far ahead, and you guess, and you listen for cracks. That's what cosmologists do. They search for changes in dark energy story, in its rhythm, in its song, because if it changes, so too does the ending. If dark energy is constant, the universe keeps expanding, forever cooling, fading, stretching toward a quiet death where galaxies vanish from one another and stars burn out one by one. But if it weakens, if it ever slows, gravity may win. The fabric may stop stretching. Galaxies could drift no longer. And then they may fall back together. A great return. Collapse. The big crunch. Stars crushed. Galaxies torn. Light compressed into silence. A rebirth, perhaps, or the end of story. But if dark energy strengthens, if it grows fiercer, the opposite happens. Not just drift, but ripping. Future, called the Big Rip, where not only galaxies, but stars, then planets, then atoms, are pulled apart by expansion itself. First, the sky empties. Then gravity fails. Then molecules fall away. Then space unravels. Matter, terrible beauty, or a final breath. But tonight, none of that is certain. All we know is that dark energy is here. And right now, it's calm, measured, steady. But we are watching with telescopes like time machines, measuring the glow of distant supernovae, the faint afterglow of the Big Bang, the patterns in cosmic microwave whispers. We look for signs, for any hint that this scene is not as still as it seems. Because if it winks, even once, we'll feel it forever. This isn't just math, it's memory, because the energy we call dark may be a relic of ancient forces, of early moments when the universe was too hot to hold still. Some say dark energy is vacuum energy, the fizz of empty space. Others call it a new field, like an unseen wind, flowing everywhere and nowhere. We don't know. But the not knowing is where the dreaming lies. You, tonight, float not only in a galaxy, but in a question. You are part of a cosmos, still deciding how to end, and the decision may lie in something without face, without sound, a pressure, invisible, yet holding the quill that writes the final paragraph of time. So we listen, we measure, we imagine. What happens if dark energy winks? Does it sleep? Does it shift? Or is it the heartbeat of something far older than even the stars? As you drift tonight into a deeper stillness, remember, what seems unchanging may yet stir. What feels eternal may sigh. And somewhere, beyond the reach of our vision, space itself may already be writing its next verse. There is a kind of silence that doesn't just settle, it grows. Tonight, as your body rests and your thoughts soften, you are not alone in this stillness. All around you and far beyond you, the universe listens too. It listens not with ears, but with expansion. And what it hears is absence, an echo of things once close, now far. Last time, we spoke of dark energy, a presence that stretches space itself, a quiet force that may flicker, may shift, may one day vanish. But now, you lie beneath the sky it left behind. Sky full of light and longing. A sky carved open by separation. Galaxies drifting apart. The fabric of space growing wider between all things. So what happens when we stop looking for what's there and begin listening for what isn't? What happens when we tune ourselves to the silence expanding between galaxies. There is a sound in every silence, not a sound you hear, but one you feel. The quiet of a room where someone just left, the hush of snow just before it falls, the cosmos as that kind of quiet. Because expansion is not just movement, it's a pause that keeps lengthening between stars, between clusters, between us and all that used to be close. Once, light from galaxies crossed the sky in millions of years. Now, it takes billions, and some are already too far. Their light, no matter how fast, will never reach us again. Not because it faded, but because the space between grew faster than the light could run. Imagine two boats drifting apart on an ocean that stretches faster than waves can travel. They wave, they shout, but eventually the sea swallows the signals. And that is the silence we are learning to measure. We do it with supernovae, those brief, bright beacons that explode like flares at the edge of time. We do it with cosmic background light, the faint afterglow of the Big Bang still echoing through space. We do it with redshift, the way light stretches as the space it crosses expands beneath it. Each method a different ear. Rest gently to the growing quiet, and we ask, is the silence still growing at the same rate? Is the expansion steady, slowing, quickening? We listen for pattern. We listen for change, because even silence, when measured closely, tells a story of what came before and what may still be coming. But this kind of listening, it's not only technical, it's emotional. To know that so much of the universe is already unreachable, that there are galaxies we will never see, stars whose light will never arrive. That takes a kind of stillness within yourself, to a willingness to accept that we live in a thinning web, a stretching space where the familiar becomes faint and the distant fades to never. Yet there is a strange beauty in that, because this silence isn't emptiness, it's structure. The universe is not becoming less, it's becoming more of what it is. And we, tiny as we are part of the listening. We build instruments that cradle photons born billions of years ago. We build detectors that feel ripples in space-time itself. We build maps of nothing, and in that nothing, we find rhythm, the silence, expanding between galaxies, becomes our tool, our teacher. It tells us where we came from, a denser past, where galaxies danced closer, brighter, more entangled, and it hints at where we're going, a future of isolation, where each galaxy becomes an island unto itself, adrift in endless dusk. But even then, we are still listening, because the silence is not passive. It changes, it shifts, it carries secrets in its widening. It holds, perhaps, the fingerprints of forces we have not yet named. Some believe that silence itself may eventually speak, that dark energy is not final, that new fields may rise, that gravity may return, that echoes from other dimensions may ripple through the quiet and make it sing. So we stay open, we stay awake, even in rest, because silence, true silence, is never empty. It is filled with possibility, with waiting, with clues. And as you lie there tonight, held gently by the gravity of your bed, you are also held by a universe that is still unfolding, still expanding, still singing its silent hymn. You are not separate from it. You are part of the stretch. Your atoms know the pace of the growing silence. Your cells remember a time when galaxies were neighbors, and your breath, soft, slow, steady, matches the rhythm of something far greater. The silence expands, and in that silence, we find not loss, but listening. We find a map, not of what is here, but of what once was and might be again. So listen, not with your ears, but with the space inside you. It knows how to stretch. It knows how to wait. It knows how to hear a silence as vast as time. And in the quiet between galaxies, between thoughts, between this chapter and the next, you'll begin to sense something stranger still. Not what space does, but what space is. Not how it moves, but what it's made of. A strange question we're still learning to ask. Is space itself woven from something deeper? You've been listening to the Dreamy Physicist, where the universe slows down just enough to dream, where particles pause, stars exhale, and questions become soft places to rest. Thank you for joining me beneath the velvet dark, where science isn't sharp but soothing. As the cosmos expands and galaxies slip farther away, your breath returns home, steady, slow, safe. The mysteries can wait until morning. But for now, from my quiet voice to your quiet night, good night from the Dreamy Physicist.